Afternoon, everybody. Just let me know if you all are hearing me clearly. Thanks. Afternoon, Gabriella, Nicholas, Emily, Ronisha. All right, just let me know if you all are hearing me though. Okay, cool. All right, so first thing, I'm working on setting up another multiple choice for you all to do. That is multiple choice number 8. All right. If you go on it right now, I don't think I hid it from you all as yet, right? But I'm still working on it. So that's multiple choice exam number 8, right? I want you all to pay special attention to that paper, please, right? It is the closest thing that you all will get to the exam that you all are getting in July, right? Your intention or your objective is to get more than 50 out of 60 in that paper. Any question that you do not understand, you can always take a picture of the question and send it to me, right? And I prefer you send the picture because if you tell me a particular question, it may not be the actual question number that I am seeing on my end, right? Because in some instances, the questions are shuffled, right? So don't tell me it's number 5 you're having a problem with, just send a picture for me, right? Yeah, so that particular paper that I'm setting up for you all, that is the June 2019 paper, right? That is the latest paper that I have, right? That I want you all to do, right? And it would be the closest thing to your actual exam, right? So enough about that paper. I'll probably finish it by this weekend, hopefully, right? So I'll let you all know this weekend when you can access it. So we're going to continue with matrices today, right? Last week we went through what is a matrix. We looked at the order of a matrix, right? The order of a matrix is how many rows by how many columns, right? And we looked at matrices in terms of transformations. We also looked at adding of matrices, subtraction of matrices. We looked at scalar multiplication of matrices, right? And what else did we look at? Right, so we looked at multiplication of matrices as well and equality of matrices, right? Now, let me just get to what I want to look at today. Right, this is basically last lap. I'm not going to come back to any of these things again, right? You need to make sure you understand what's going on here. So let's start. So one of the first things that you all need to know about a matrix is that this particular matrix here is a 2 by 2 matrix, right? It's a 2 by 2 matrix because we have 2 rows and we have 2 columns, right? So this is a row. So there's row 1 and this is row 2. So therefore the first number has to be a 2, right? So this number here is a 2. This is 2 rows we have here. And then we have 1 column, we have another column, so we have 2 columns. So it's a 2 by 2 matrix, right? A lot of the questions that you get in the paper 2 are related to 2 by 2 matrices. Now, there is something that you all need to be able to find, and that is called the determinant of a 2 by 2 matrix, right? Now, the determinant of a 2 by 2 matrix is given by this symbol here. It is written as the modulus of A. In maths, when you see two vertical lines like this, and there's a letter of some sort in between, right? These two lines here are what we call modular signs, right? So it's just a letter with two vertical lines on either side of it. That's all you need to know. So that's how you write determinant. Now there's a formula to find the determinant of a 2 by 2 matrix. What we do, we take this element here, which is A, and we multiply by D, right? So that's the first part. So we say A multiplied by D, and then we must subtract B multiplied by C. So the B in this case here is this by this, right? So it's A multiplied by D minus B by C. So this is a formula that you all need to know, and this only applies to a 2 by 2 matrix, right? For a 3 by 3 matrix is something different. So only for a 2 by 2 matrix, the determinant is found by multiplying A by D and then subtracting B by C, right? For example, let's say we have a matrix here, and the matrix is 2, 1, minus 4, minus 3, and we want to find the determinant of this matrix. Again, you need to know what the formula is. The determinant is equal to A by D minus B by C, right? So you all need to remember this formula. A by D multiplied by B by C. Now, I don't like learning off formulas. What I prefer, I need to understand the concept itself. So I know I'm going to take this and I'm going to multiply by this. That's the first thing I'm going to do. This multiply by this. So 2 multiplied by minus 3, I'm going to get minus 6. The next thing in the formula is that we need to subtract. We're going to subtract, but we have to multiply B multiplied by C. So it's 1 multiplied by minus 4. All right? 1 multiplied by minus 4 gives me minus 4. Now, I deliberately gave this question here is because students make mistakes when it comes to minus signs. So we have minus 6 minus minus 4. Minus 6 minus minus 4 is the same as saying minus 6 plus 4, right? And minus 6 plus 4 is equal to minus 2. Now, some students have problems with when they work with what we call directed numbers. The easiest thing to do when you have questions like this is draw a simple number line. You have minus 6. So minus 6 is here, right? This is minus 5. This is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, right? And I just put some numbers on a number line here. And when you are doing the subtraction, we are working out minus 6 plus 4. So you're starting at minus 6, right? That's our starting point. And we're going to add 4. When you are adding on a number line, you move to the right. So you're going to go 1, 2, 3, 4. So my answer has to be minus 2, right? Now, because more than likely you all are just getting the multiple choice exam, you're not going to have your calculator to use. But if by chance they give you a written paper, you can use the calculator, right? A minus 6 plus 4 gives me minus 2, right? So let's look at the next example here. So we have a matrix again. The matrix is 1 minus 2 minus 3, 2. And you want to get the determinant of the matrix, right? Again, we're going to use the formula. So make sure you have this in your memory. It is AD minus B multiplied by C, right? Just need to know that formula. So what we're going to do, we're going to say this 1 multiplied by this 2, right? 1 multiplied by 2 gives me 2. We know in the formula we have a subtraction, right? And then we're going to take this minus 2 and multiply by this minus 3. So minus 2 multiplied by minus 3 gives me plus 6, right? So therefore, all we're working out here is 2 minus 6. And 2 minus 6 gives me minus 4, all right? So just to make sure we have this, I'll give you a 2 by 2 matrix here now. Let's say 1, 4, minus 2, and let's say 2. All right, I'm calling this matrix A. I want you all to tell me what is the modulus, or what is the determinant of this matrix, right? So I'll give you all a minute to work that out for me. What is the determinant of that matrix A that I've written on the side here? This one here. What is the determinant of this matrix here? Alright, I've seen everybody, well, a few people saying 8. Let's see if that's correct. So the formula is AD minus BC. So we're going to take the 1 and multiply by the 4. And then we're going to subtract minus 2 multiplied by 2. Right? 1 multiplied by 4 gives me 4. Minus 2 multiplied by 2 gives me minus 4. 4 minus minus 4 is the same as saying 4 plus 4. So therefore the answer is 8. So you all are correct. The answer is 8, right? So that is how we find the determinant of a matrix. Now, there is a special matrix, what we call a singular matrix. Now, a singular matrix is a matrix that has a determinant of 0, right? So look at this matrix here. We have a matrix 3, 2, 6, 4, right? If we work out the determinant of this matrix here, we're going to say 3 multiplied by 4, right? That gives me 12. And we have to subtract 2 multiplied by 6, right? 2 by 6 gives me 12. And what we get here is 0 as the determinant. Now, if the determinant of a matrix is 0, it is called a singular matrix, right? So a matrix that has a determinant of 0 is called a singular matrix. All right, let's check something here. I wanted to show you all a particular question. Okay, I'll ask this question just now, right? Okay. So that is what a singular matrix is. Once the determinant is equal to 0, the matrix is considered a singular matrix. Now, how does CSEC bring a question when it comes to a singular matrix? Look at this question here. We want to determine the value of P. So you want to determine the value of P given that the matrix A is singular, right? So this is my matrix. The matrix is P3, 8, 4, right? Now the fact that the matrix is singular, that tells me that my determinant is equal to 0, right? That's what that means. My determinant is equal to 0. So what that really means is that determinant, right, is, remember it's AD minus BC, right? And that value has to be equal to 0. So look at something here. When you have a question like this, what you will do, you will say that since the matrix is singular, the determinant is equal to 0. Now, we go ahead and we find the determinant. So we say P multiplied by 4, right? P multiplied by 4 gives me 4P. Then we have to take the 3 and multiply by 8. So 3 multiplied by 8 gives me 24. So 4P minus 24 is my determinant. But the fact that the matrix is singular, I have to put that equal to 0, right? And what we really have here now is an equation that we need to solve for P. So 4P we're going to take the minus 24, carry it on the right hand side, it becomes 24. So therefore P is simply 24 divided by 4. Oh, sorry, this is wrong. This is 6, right? So P is equal to 6, not 8, right? So this is how they bring the question when it comes to a singular matrix, right? What about something like this one? So in this particular question, we have determine the values of P for which a matrix is singular. Now, pay attention to some of these matrices question. Notice what they said. They said values, right? When they say values of something, it means that you're going to get more than one answer, right? So, if the matrix is singular, we know that the determinant is equal to 0. So therefore, what that means is that if I take P and I multiply by 2P, right? P multiplied by 2P here will give me 2P squared, right? Because P multiplied by P gives me P squared. And then I'm going to subtract 8 multiplied by 4. 8 4s are 32. So therefore 2P squared minus 32 is equal to 0, right? And what you're doing here now, you're trying to solve this equation. The first thing we need to do is to move the 32 on the right hand side. Your next step is to divide by 2 to get rid of this 2 here. So 32 divided by 2, right? That gives me 16. Alright? So what we end up with is P squared equal to 16. Now here's what some students do, right? They get P squared equal to 16, and then they come and they say, well, P is equal to the square root of 16, so P is equal to 4. And that's it, they're done. Right? That is not the full answer. That's only part of the answer, right? Because what happens is that the square root of 16 is actually equal to plus or minus 4. So the question asks for the values of P, right? So P equal 4 is one value and P equal to minus 4 is one value, right? So I've spoken about this in class already. So the square root of 16 is equal to plus or minus 4. And why? Because if I take 4 and I multiply by 4, I'm going to get 16, right? So 4 squared is 16. If I take minus 4 and I multiply by minus 4, I am going to get 16 as well. So the thing is, when you find the square root of anything, the answer is always plus or minus something, right? So in this case here, you're going to get two values of P. You're going to get P is equal to 4. That's one answer. And you're going to get P equal to minus 4. That's my second answer. All right? All right. So, yes, sir. Just find a question here to give you. Alright, so look at this. This is an actual exam question here, right? So they have a matrix L, right? The first part, they want us to calculate in terms of X the determinant of L, right? So what I want from you, what is the determinant of the matrix L? That's the first thing I want. What is the determinant in terms of X? Alright, so I've seen John and Emily saying x squared minus 4. So the question wants, calculate in terms of x the determinant of L. Right? So the determinant of L, right, is written like this. And it's equal to, remember you have to take A by D. So it's x multiplied by x minus, we're going to have to take the 4 and multiply by the 1. So it's 4 multiplied by 1. So x multiplied by x gives me x squared minus 4 by 1 gives me 4. So the answer for the first part is this. This is the answer for the first part. X squared minus 4. Alright? Now, the second part now, look at the question. The question says, calculate the values of x, given that L is singular. So what's the answer for part 2? Alright, so I'm seeing Emily saying plus 2 and minus 2. Right? John saying the same thing. And Tyrese. Yeah. Alright, so that's basically it. So they're saying L is a singular matrix. So what that's telling me is that the determinant of L, right, is equal to 0. That's what that is telling me. But you already worked out the determinant. You got x squared minus 4. Right? So x squared minus 4 is equal to 0, right? Because my determinant is equal to 0. It's a singular matrix. So therefore we can write x squared is equal to 4, right? You carry the minus 4 on the right hand side. And therefore x is the square root of 4. Again, I told you all, square root is really plus or minus. So the square root of 4 is plus or minus 2. So the values of x that they want will be x is equal to 2 and x is equal to minus 2, right? If you just put this as your answer, this is correct. If you put this, that's still correct, right? So this is how the examination question is going to come if it were a paper 2 question, right? That's now. Right, so that's what we call the determinant of a matrix. Now, let's go back a little bit. Where am I? Right, so when it comes to a 2 by 2 matrix, there is something called the adjoint of a matrix, right? So when it comes to a 2 by 2 matrix, there's something called the adjoint of a matrix. What does that mean? What we're doing with the matrix, we're making some changes to the matrix, right? So here's the thing. Now, like I said, I try to understand process. I don't like to learn on formulas. I don't like that at all. So the adjoint of a matrix, here's what you need to remember. You see these two positions here, the A and the D, you swap those positions. Now, this matrix here on the right hand side is my adjoint matrix. So I'm swapping the positions of A and D. And what you're going to do with B and C is simply put a minus sign in front of B and a minus sign in front of C. So the adjoint of a matrix, right, is given by this. It's given by this here. That's the adjoint of a 2 by 2 matrix. You are swapping this position with this position, right? So you swap those, and in the case of B and C, all you do, you put a minus sign in front of them. So if I had a matrix here, this is just an example. If we have a matrix 2, minus 1, 4, 1, first thing we do, we swap these two positions, right? So notice where the 1 is now, and notice where the 2 is. And all you're going to do now with B and C is to put a minus in front of this. So therefore this minus is going to disappear. So you're going to end up with just 1. And the 4, you're going to put a minus in front of it. So this is my adjoint of the matrix, right? Alright, so let me ask you something then. So if I have a matrix given by P, and the matrix is, let's say, 4, minus 2, 1, 2, right? I have a matrix here. I want you all to tell me what is the adjoint of the matrix, right? Now when I'm calling out matrices, I go like this. Like I said, this number, this number, this number, this number, right? So I want to know what is the adjoint of the matrix P. I just want to find out something. Janelle, are you following with what I'm talking about right now? All right, so I seen John saying 2, 2 minus 1, 4. All right. So we want the adjoint of that matrix, right? So the adjoint of that matrix is going to be this. We're going to swap the 4 and the 2. So that's the first thing you're doing. So you're going to put 2 here and you're going to put 4 here. Then we're going to put a minus sign in front of the B and the C. So this is going to become 2 and this is going to become minus 1, right? So it's a simple process. You just need to remember what you have to do. So this is what we call the adjoint of the matrix, right? So why do we need the adjoint? Now, there is something that you all need to be able to work out when it comes to a 2 by 2 matrix, and that is called the inverse of a matrix, right? So let's look at something here now. So we're talking about something called the inverse of a matrix. So it's the inverse of a matrix, right? When we have a 2 by 2 matrix, that's this, and we want to find the inverse. So inverse of a matrix is written like this: a to the power minus 1. That is the inverse of a matrix, right? There is something that we need to remember, which is this. You need to know this. Please, you need to know this, right? In the exam, they can give you a matrix and they can tell you, find the inverse of that matrix. So the inverse of a matrix is simply 1 divided by the determinant multiplied by the adjoint of the matrix, right? That's how we find the inverse of a matrix. So for example, let me give you an example. Let's say we have a matrix here, which is A, and that matrix is, let's say, 1, minus 2, 3, and let's say this is 2, right? So I have this matrix, and I come and I ask you, find A inverse, right? Now you need to know what that symbol means, right? That symbol means the inverse of a matrix. So here's this. So the first thing we need to do before we could find the inverse of a matrix, we need to find the determinant. So the determinant is written like this. We have to take 1 multiplied by 2, and we're going to subtract minus 2 multiplied by 3, 1 multiplied by 2 gives me 2 minus, and minus 2 by 3 gives me minus 6. So therefore, my determinant is actually 2 minus minus 6, which is 8. So my inverse of my matrix, right, is given by 1 over the determinant, which is A, multiplied by the adjoint of the matrix. The adjoint of the matrix, we have to do a little transformation here. So 2 and 1 is swapped. This will become 2 here, and this will become minus 3. Now, some students, what they will do, they will simplify this even further. They will say A inverse is equal to, and they're going to take the 1/8 and multiply by every one of the elements inside it. So what they're going to end up with is 2 over 8. This could be 2 over 8. This is minus 3 over 8. And this is 1 over 8. Both answers are correct, right? If you put this, you're still going to get it correct. If you put this, you're going to get it correct, right? I typically do not simplify it. I leave it as is, right? If you want to show them that you know what you're doing, you could go ahead, right? It's up to you, right? But either answer is correct, right? So this is how we find the inverse of a matrix. Finding the inverse of a matrix is incredibly important, right? So I have another example here. So we have a matrix A. This is the matrix A, and you want to find the inverse of that matrix. First thing, before you can find the inverse of a matrix, we need to find the determinant. This is the first step, step 1, right? I showed you how to find the determinant. So it's AD minus BC. So it's 2 multiplied by 1, subtract 4 multiplied by minus 3. 2 by 1 gives me 2, 4 multiplied by 3 gives me minus 12. 2 minus minus 12 is 14. So my determinant is 14. Now, all we need to do now is to write down what the inverse is. So it's 1 over the determinant, which will be 1 over 14, and we have to put the adjoint matrix. So you're going to swap this position with this. So the 1 and the 2 swaps, right? And then you have to put a minus sign along this one here. So this is minus 4 and this is 3. So this is how we find the inverse of a matrix, right? So look at this question here. This here is an exam question, right? So we have a matrix M. Sorry about that. Right, so we have a matrix M, right? We have a matrix M here, and the matrix is 3, 1, 2, 6. The question wants us to find the inverse of M. I'll give you 2 minutes. What is the inverse of M? Alright, so while you all working out that, with respect to the CXC exams, I see that they're saying that the exam is scheduled to start July the 26, 27, somewhere there, right? Just for your information, I will only be teaching until with me, so I'm only teaching until the end of June. But you will still have access to me, right? You can call me, you can WhatsApp me. You all will still get access to the website, right? You'll get access to the website right up until the exams, right? Only after exams are finished, then you won't have access, right? But classes, I will stop classes at the end of next month, okay? Because we've covered the entire syllabus already, right? What I'm doing is just reviewing to make sure that you know all these things. right? Typically, what would happen is that you all would have written exam already, right? I usually stop classes in May, right? But because of the current situation, I don't want you all to be just sitting, not reviewing your work, right? A lot of you all are ready, more than ready to write the exam, right? I don't want you all to slack off. I need you all, I know a lot of you all, if they go through with this paper 1 and SBA, almost all of you all going to get ones. I will see that, I can see that happening, right? Just do what I'm telling you to do, okay? Let's see if anybody got the inverses yet. All right, so I'm waiting for an answer from you guys. So just remember the steps. The first thing we need to do, we need to find what the determinant is, right? And once we have the determinant, then we can write what the inverse is. Alright, so I've seen John and Emily. Alright. Alright, so you all seem to be getting something similar, right? So let me just make a little space here. Right, so this is the question we're working out, right? Alright. So the first thing we need to do, first step, is to find the determinant, right? So my determinant of M is written like this, and it's AD minus BC. So it's 3 multiplied by 6, right? Minus 1 multiplied by 2, right? So 6 3s are 18 minus 2. Right? So this gives me 16. So therefore my inverse, right, of this matrix here is simply 1 over 16, right, because 1 over the determinant multiplied by the adjoint matrix. Just remember how to get the adjoint matrix. You're going to swap the positions of A and D, so therefore 6 is going to come here, 3 is going to come here, you're going to put minus 1, and then you're going to put minus 2, right? So you can leave your answer as this if you want, that's fine. They cannot penalize you for this, that's the answer, right? Right? But some students, they do this. They say 6 over 16 minus 1 over 16 minus 2 over 16 and 3 over 16, right? Either answer is correct. This is correct, this is also correct, right? Any one of them you put, you should get the marks. They should not penalize you for that, right? So this is an exam question. you need to be able to find the inverse of a matrix. Cool? Let's see now. Now, there is a special matrix, a special 2x2 matrix, right? And it is called the identity matrix, right? You've met it before, you know. So there's something called the identity matrix, right? And we usually use the symbol I to represent the identity matrix. Now, the identity matrix is the matrix 1, 0, 0, 1. You need to know this, right? This is what you call the identity matrix. Now, one second. We'll have some mistakes here. I have a question for you. 2 questions actually. And I want to give you one time. I want you to look at these 2 questions here. Question 27 and question 28, right? I want you to pay special attention to these 2 questions. I'm almost 100% sure that you will be getting these 2 questions in your exam, right? So look at question 27 for me, and I want you to tell me what is the answer for question 27. Alright, I've seen Emily saying B. What about everybody else? Alright, I see Nicholas and Kyle also saying B. Right, so the whole class saying B, right? So let's look at that. Now for question 27, right, like I said, chances are you're getting the exact same question in your exam. Eh? So we have 2 matrices are conformable for multiplication if, now remember, if you're multiplying 2 matrices, right, if I have a matrix A and a matrix B, and one of them is M by N, right? That's the order of the matrix A. And what's supposed to happen is that this has to be N and this could be P. Alright? So in order to multiply 2 matrices, this number, right, and this number has to be the same. These 2 numbers must be the same. And my final answer, the matrix for the final answer, let's call it C, is going to be an M by P matrix, right? So it's an M by P. So the final answer is going to be a M by P. So the key thing here, in order for two matrices to be multiplied, is that this number and this number has to be the same. But this number here in A, right, let me use a different color here. So this number here is the number of columns in E. So it's the number of columns in E, right? That's what that number represents. And this here, this N here, represents the number of rows in B, right? So like you all said, the answer is B, is the number of columns in A and the number of rows in B. This is the answer, right? So you all making me proud here, right? You all actually know the work, right? So the answer is B. How about question 28? Question 28 is a new question that came, right? So question 28, I don't think you've ever seen that before. So what is the answer for question 28? Alright, just for you all to remember, because so they're talking about the identity matrix. The identity matrix I is equal to 1, 0, 0, 1. Right? That's the identity matrix. So the determinant of the identity matrix is what? What is the answer? Alright, I've seen Tyree saying A, Aaron saying A. Everybody else, what's the answer? You all should breeze through this. Alright, I've seen Emily also saying A, Xavier saying A as well. So look at it, they want us, so this is the identity matrix 1, 0, 0, 1, and they want us to find the determinant. So the determinant of the identity matrix, which is written as this, is equal to AD minus BC. So it's 1 by 1 minus 0 by 0. 1 by 1 is 1, and 1 minus 0 gives me 1. So the answer is E, right? So I am telling you all, these are the answers for these two particular questions. Please, when you get the exam in July, do not get it wrong, right? These questions are going to come in the exam, right? All right, so let me just go back to this thing here, because I realize I have a slight mistake here. Let me fix it one time. Hold on. All right, so the identity matrix is an important matrix, right? So it's 1, 0, 0, 1, but there are some rules that you need to remember. If I take any matrix, any 2 by 2 matrix, and I multiply it by the identity matrix, I'm going to get back the same matrix. If I do the multiplication in the reverse order, so I take the identity and multiply by the matrix, I'm going to get back the same thing here, right? Just to give you an example, let's have a matrix 1, 2, 2, 1, right? Let's say we have this matrix here, and I want to multiply this matrix by the identity matrix. The identity matrix is 1, 0, 0, 1, right? So this is, let's call this matrix A, and let's call this the identity matrix. If I multiply this, right, I'm going to apply my rules to multiply, row by column. So 1, this 1 by this 1 gives me 1 plus this 2 multiplied by 0. So therefore, I'm going to get 1, right? To get this element here, it's going to be this 1 by 0, which is 0, and 2 by 1 gives me 2. So I'm going to get 2 coming here, right? Then 2 by 1 gives me 2, and I'm going to add it to 1 by 0. So this is going to be 2. And then when you work out the last element, you're going to get the same thing. So therefore, any matrix, any 2 by 2 matrix multiplied by the identity matrix, I'm going to get back the same matrix, right? And the same thing applies if I do it in a reverse order as well. So if I do 1, 0, 0, 1, and I multiply by the 1, 2, 2, 1, I know that the answer is going to be 1, 2, 2, 1, right? So this is what this rule is saying. This is what this rule is saying, right? And the most important one here is this. When we have a matrix and we multiply it by its inverse, we get the identity matrix. This is an important concept that you need to know. So a matrix, matrix A, multiplied by its inverse, I will get the identity matrix, right? Now, why is that important? That is important because one of the questions that you get in the exam concerning matrices is to solve a pair of simultaneous equations, right? So let's take a look at that now. Where did I put that? All right, so take a look at this. Now in the exam, if it were paper 2 you were getting, and we had to solve a pair of simultaneous equation using a matrix method, right? There are several ways to solve a simultaneous equation. We can use the process of substitution, that's one method. We can use the process of elimination, that's the next method. We can draw a graph to show 2 lines, and where the 2 lines intersect, that's our solution. That's a third method. There's a fourth method. A fourth method is to solve using the matrix method. So the question is this. You want to solve the following simultaneous equations, that's these 2 equations here, using a matrix method. Now I want you to understand the language. When they ask you to solve a simultaneous equation, what you are really finding are the values of x and y that satisfies both equations, right? So the objective when you're solving a simultaneous equation is to get x equal to some number. You want to get y equal to some number, right? If I had to do this graphically, right, what I would get is something looking like this, another equation. Now this may not be the actual equations here, I just draw in something here. So you would draw the 2 lines because this here is a straight line and this is a straight line. Where they intersect, right, I'm going to get an x value and I'm also going to get a y value, right? Those values give me the same answer that I'm going to get here. It's going to give me this answer, it's going to give me this answer, right? But this particular method, we're going to do what we call a matrix method for solving a pair of simultaneous equations. The first thing, before you can solve any simultaneous equation, it must be written in a format that looks like this. It has to be something x, something y equal a number. Something x, something y equal a number. In all the years I've seen CXC bring questions, only once have I seen them bring the question where it wasn't written like this and you had to write it in the correct format, right? So it has to be written like this. It has to be something x plus something y equal a number, something x plus something y equal a number. The 2 equations has to be like that because you have to be able to look at equations and write it as a matrix, right? So here's what we're going to do. So what we're concerned about here are the coefficients. We're looking at the numbers in front of the x. This is 4. There's no number in front of the y here, so this we know has to be a 1. This is a 3 and this is a 2. So the first thing we're going to do, we're going to take those numbers and we're going to make up a matrix. So this is a 2 by 2 matrix. This is where I got the 4, I got the 1, I got the 3 and the 2. Some students, they can't even see that, right? But all I'm doing, I'm taking the coefficients of the x in the first equation, the coefficient of y in the first equation, and I'm doing the same thing for the second equation. So you're just looking at the equations and you coming up with this, right? That's the first part of the question. In the exam, that's typically what they ask you to do. Then what you're going to do now, you're going to write xy. It's always going to be xy. X on top, y below, right? And then on the right hand side, all you're doing here now is taking these numbers. You're taking this 1 and you're taking this 2, right? So this is the first step that we use when we're going to do or solve this using the matrix method. All right? Hope you're all with me so far, right? So that's my step 1, first thing. What we're going to do now, what we're concerned about is this 2 by 2 matrix here. You're going to have to find the inverse of that 2 by 2 matrix. So just to make sure you're all following me, I want to know what is the inverse of that matrix. All right, I'll give you 2 minutes. What is the inverse of that matrix? Right, I've seen Darrell and Emily give me an answer here. All right, I'll give everybody a minute again. All right. Okay, so Kyle getting the same thing, John getting the same thing. All right. So we want to find the inverse of this matrix here, right? That's a 4, 1, 3, 2. So here's what we need to do. We need to find, let's call the matrix M, right? So I'm just calling it M so that you follow what I'm doing here. So let the matrix M be 4, 1, 3, 2, right? So the determinant of this matrix M is given by AD minus BC. So it's 4 by 2 minus 1 by 3, right? So this is 4 2s are 8 minus 1 by 3 is 3. So 8 minus 3 gives me 5. So my inverse of this matrix here, which I'm calling M, is equal to 1 over the determinant, which is 5. And we're going to have to write the adjoint of matrix M. So you're going to swap the position of the 2 and the 4. So 2 and 4 come in here. And we're going to put minus 1 here, and this will be minus 3, right? So let me just see what you all wrote there. 2 minus 1 minus 3, 4. 2 minus 1 minus... Right, so correct. So what you all telling me here, for the inverse, that is correct. So this is an important step, right? So let's go to step 2. So what we have to do, well, in this case here, I worked it out and I call it A. Doesn't matter what you call it. So what you were doing, you were finding the inverse of the matrix, right? So the inverse of the matrix is this. This is what you just did, right? So that is step 2. So step 2 is to find the inverse. The third step now, third step. Now, the third step is this thing that looks a little complicated here, but it's not really, right? Let me just make it a little bigger, find it a little too small. All right. Yes, I know it's looking complicated, but it's not really. So what we're going to do, remember what we started off by saying. The first thing we had in step 1, we had 4, 1, 3, 2, right? Multiplied by xy is equal to 1, 2. That's the first thing we had in step 1, right? We just worked out the inverse of the matrix, right? Now here's the thing. You see the rules when we spoke about the identity matrix? That is what is coming into play. So the first thing, the inverse of a matrix multiplied by the matrix will give me the identity matrix, right? That's a rule. We did that, right? Also, if I take my identity matrix and I multiply by a matrix, I am going to end up with the same matrix. Also, if I do the reverse multiplication, right, A by I, I'm going to still get back my same matrix. So this here is what we are making use of in order to solve this equation. So this is what we had from step 1. You already worked out the inverse, which was this figure here. So here's what you're doing. You're starting off with this equation here in step 1, and we're going to multiply both sides of the equation by the inverse. So you're going to put the inverse here, and you're going to put the inverse here. Remember, whatever you do with an equation, you must do it on both sides of the equation. So I am multiplying both sides of the equation by the inverse. So look at carefully what's happening here. So look at where the inverse is, and look at where the inverse is. Right? That's all I'm doing. I am putting the inverse here, and I'm putting the inverse here. Now, look carefully what's going on here. So this matrix, this here, multiply by this will give me what? Multiplying So can somebody tell me, when I multiply those two matrices, what am I getting? Anybody? When I multiply those two matrices, what am I getting? It's not a trick question, and it's just one answer. Yes, John, that is correct. It's the identity matrix, because you have this matrix here, and this here is the inverse of that matrix. So that is actually this rule here. So when I multiply those two matrices, I'm going to get the identity matrix, right? And when I take the identity, so this here multiplied by this gives me 1, 0, 0, 1, right? That is true. But when I take the identity matrix and I multiply by xy, I know the answer has to be xy. So in class, when I showed you all this, I kind of showed you all here what? When you multiply all of this, all you're getting is this, xy. So when you're trying to work this question out, all you're really working out is on the right-hand side of the question. So you're working out this here, which was your inverse, and you're multiplying it by 1, 2. So what I told you all in class, I said multiply this by this first, and don't do anything with the 1/5. Leave the 1/5 for last. So when you are multiplying this here, you're multiplying a 2 by 2 matrix by a 2 by 1 matrix, right? So what is happening is that we're going to say row, we're going to take this row and multiply by this column here. So 2 multiplied by 1, that's what you're working out here. And we're going to add that to minus 1 by 2, that's this. And then we're going to take this row and multiply by this column here. So minus 3 by 1 gives me, well, you have to multiply that. And then 4 by 2. So all we're doing here, we're simplifying. It's only looking complicated, but it's not, right? So 2 multiplied by 1 gives me 2. And then minus 1 by 2 gives me minus 2. Then the bottom piece will be minus 3 multiplied by 1, which is minus 3. And then 4 by 2 gives me 8. So 2 minus 2 gives me 0. And minus 3 plus 8 gives me 5. So now we have a scalar multiplication to do. You have 1/5 multiplied by 0, 5. 1/5 by 0 gives me 0. And 1/5 by 5 gives me 1. So the solution to this question here is x is equal to 0 and y is equal to 1. Alright? Now, more than likely, if you are getting a multiple choice, chances are they may not give you this, obviously. I don't feel so. Right? But if it were a paper 2, then definitely it's a question that you can get. Right? So this is the method by which we solve a pair of simultaneous equations. Alright? So let me just check some questions here again. All right, so basically that's it for matrices. Let me just give you a question here. All right, so look at this. This is an examination question here. Given that D is equal to this matrix here, is a singular matrix, and determine the values of P. So what are the values of P for this question? Right, so I'll give you 2 minutes to work that out for me. Alright, so we're working out the values of P here. Alright, so I seen Emily saying 2/3 and minus 2/3. Anybody else? Alright, so okay, so let me work it out now. Alright, so they're telling us that the matrix is singular, right? So once the matrix is singular, we know that the determinant is equal to 0. So once they tell us this, the matrix is called D, so the determinant of D is 0. So all you need to do, you need to write the determinant of D is equal to 1 by 4, right? Remember it's AD minus BC, minus 9p multiplied by p, which is 4 minus 9p multiplied by p gives me 9p squared, right? But we know that this here, that answer has to be equal to 0. So the determinant is equal to 0. So therefore, 4 minus 9p squared is equal to equal to 0. 0. Right? So we could say minus 9p squared is equal to minus 4. We don't want to work any minus 4 here, so we could say 9p squared is equal to 4. P squared is equal to 4 over 9. So therefore P is equal to plus or minus the square root of 4 over 9. Right? So therefore P is equal to plus or minus the square root of 4 over 9 is actually 2 over 3. So you can leave your answer as this, and this will be correct. Or we can go and tell them, let P equal to 2/3. That's one answer. And P is equal to minus 2 over 3. Right? Notice the question asks for the values of P. Right? Well, I put values. Right? So the answer is plus 2/3 minus 2/3. Alright. For this question here, right? So they have two equations here, right? A simultaneous equation. If we have to solve this, the first thing we need to do is to write it in a matrix format, right? So we're going to write 2, 5, 3, 4 multiplied by xy. Xy equal to 6, 8, right? Here's what I want you all to do for me. I want to know what is the inverse of that matrix. What is the inverse of this matrix? Alright, I've seen John give me an answer there already. Let's see. So the matrix is 2, 5, 3, 4. Right? So let's just call our matrix A. You can call the matrix anything you want. Alright? So the first thing we have to do is to find the determinant of A, which is 2 multiplied by 4 minus 5 multiplied by 3. Right? So that's 4 2s are 8 minus 5 3s are 15. So this is minus 7. Right? Next thing we need to do, we need to find so we can write the inverse now one time. So the inverse of the matrix is given by, we swap the position, so we put 1 over 7, but it's minus 1 over 7, by the adjoint of the matrix. So you're going to put 4 here, 2 here, minus 5 here, and minus 3 here. Right? So sometimes in the exam, they give you like 2 marks just for this, and you can do this like quickly. So this is the inverse here. Alright, so I see in Emily, Kyle, Aaron. Alright, good. So that's the inverse. Now, if we have to solve this equation here, right, what we're going to have to do is to multiply both sides of the equation by the inverse. So we're going to do minus 1 over 7 by 4 minus 5 minus 3, 2, multiply by 2, 5, 3, 4 by x, y is equal to minus 1 over 7, 4, 2 minus 5 minus 3 by 6, 8, right? And we know that when you multiply everything on this side here, all you're really ending up with is xy. That's all you're ending up with, right? So what I want you all to do for me, you already have the inverse. I want you to work this out here, multiply this out for me, and tell me what you're going to get for x and y. Multiply that out and tell me what you're going to get for x and y. Right? Don't do anything with the 1/7 as yet. Work out the 2 by 2 matrix, multiply by the 2 by 1. So seeing John, Emily, so okay, minus 16 and minus 2. All right. Alright, so let's multiply this out here. I'm not going to do anything with the 1/7 as yet. I'm going to just leave that as is, right? So I know, so I'm going to use my calculator to do this, right? So you know the answer on top here, right? I'm going to work it out in one shot here because I don't have enough space, right? So you know you should get, there's two numbers here. To get this first number here, we need to take this row and multiply by this column, right? So that's 4 by 6 gives me 24 plus minus 5 by 8. So minus 5 by 8, and that gives me minus 16, right? Then we need to take this row and multiply by this. So minus 3 by 6 gives me minus 18 plus 16 gives me minus 2. Right? So this is minus 2 coming here now. But then we still need to multiply by the 1/7, right? So I'm just going to work it out here. So this is xy. So this here will be minus 1/7 by minus 16 will give me 16 over 7. And then minus 1/7 by minus 2 gives me 2 over 7, right? So therefore my answers are x is equal to 16 over 7, right? You can write that as a mixed number if you want, or you could just leave it as that. And y is equal to 2 over 7, right? So this is how we solve a simultaneous equation using the matrix method. Let's see if I get any other questions for you all here. So let's look at this next examination question here. All right, I'll give you 2 minutes or something to work it out. So we have A, B, and C are matrices. So they give us what the matrix A is, what B is, and what C is. And they are telling us that A multiplied by B gives me C. Find the value of x and y. So I want you all to work out x and y for me. Alright, so please try the question. Let me see what you all getting. Alright, so see, Emily says she get 4 and 3. No, she thinks so. Let's have a look at this. So the question is saying A multiplied by B gives me C, right? So what you're multiplying is 2, 1, right? Multiplied by B, which is 1x y minus 2. And this is equal to 5, 6, right? Now, before we work it out, let's check something here. So this first matrix A here, we have one row and we have 2 columns. So this is our 1 by 2 matrix, right? That's the order of the matrix. A is a 1 by 2 matrix. In the case of B, we have 2 rows and 2 columns, so it's a 2 by 2 matrix, right? So remember, when you're multiplying 2 matrices, this number here and this number has to be the same, and the final answer will be a 1 by 2 matrix, right? Which is 1 row and 2 columns, that's true. Look at this. This is a 5, 6 here. Now, what's going to give you a problem is how we're going to multiply this, right? Now, you have to remember, it's always row by column, right? So it's this row here, right, multiplied by this column here will give me my first number, right? So 2 by 1 gives me 2 plus 1 by y gives me y, right? So that's my first number in this matrix, because we know the final answer has to be a 1 by 2 matrix. Final answer has to be a 1 by 2 matrix, right? So the matrix must look like this. So this is the first number in that matrix. Then we're going to take this same row and multiply by this column to get the next number, right? So 2 multiplied by x gives me 2x. So this is 2x. And then 1 by minus 2 gives me minus 2. So this is minus 2 here, right? So this is one number or one variable, and this is the next variable. And that is equal to 5, 6, right? I know it's looking a little confusing, right? So if you have this matrix here, this whole matrix here, equal to this whole matrix, what we can say is that 2 plus y is equal to 5, right? So this number here has to be equal to this number here. So therefore y is equal to 5 minus 2, so y is equal to 3. The next thing we need to do now, we need to say that 2x minus 2 has to be equal to 6. So 2x minus 2 is equal to 6. So 2x is equal to 6 plus 2. So 2x is equal to 8, and therefore x is equal to 8 over 2. Therefore x is equal to 4, right? So the answers are 4 and 3, right? So 5 marks for this, right? And it didn't require much working, you know. You just need to understand how we multiply the two matrices. So any questions about what I did here? All right. Okay, so Aaron saying no, you don't understand. Okay. So let me start over. So understand what the question is saying. They are saying that AB is equal to BC, right? So this is so AB is equal to C. That's what they're telling us that, right? And if we look at the two matrices or all the matrices, so matrix A, this particular matrix is a 1 by 2 matrix, right? Because you have one row, but you have two columns. So it's a 1 by 2 matrix. Matrix B, we can tell that it's a 2 by 2. And matrix C, it's a 1 by 2 matrix, right? So you all should be able to see what the order of the matrix is. Now, in order for us to be able to multiply two matrices, because look at something here, you're multiplying A by B. If you're multiplying A by B, it means that this number here, which is 2, and this number here has to be the same before you can multiply the matrix, right? So they are the same, and the final answer is going to be a 1 by 2 matrix. So look at this. So the final answer has to look like this. So all I'm doing, I am substituting each of the matrices into this equation that we have here, AB equal to C, right? So you write A exactly as they gave you it, which is 2, 1, So A was 2, 1. So it's 2, 1. And I'm multiplying that by B, which is 1x y minus 2. And that is equal to another matrix, which is 5, 6. Right? So let me know if that makes sense up to that point. Oh, okay. So you're saying you understand how I get it. Okay, cool. Right? So all I'm doing here is multiplying row by column. When I multiply the left-hand side, I should get 1 by 2 matrix. Right? So I should get two numbers. So that's what happened here. You needed to get two numbers here. This was one and this was the next one. All right? Let's look at this one here. This is just part B of that same question actually. So they gave us a matrix. They have a matrix R, right? It's 2 minus 1, 1, 3. The first part, how do we show that the matrix R is non-singular? Look how much marks for this here. 2 marks. Show that the matrix R is non-singular. Now the word non-singular means it is not singular, right? So how are we going to show that? Alright, so I seen John saying find the determinant. And when you find the determinant, what you're doing, or what you say? So what else you need to say in order to get the marks? See Emily saying determinant for the matrix is 5. What else you need to say? Right, so what John is saying, that is correct. So what he's saying is that since the determinant isn't 0, then R is non-singular. Right? So you want to show that R is non-singular. So the first thing I would do, I would find what R is. What is the determinant of R? So the determinant of R is 2 multiplied by 3 minus 1 by 1. So 2 multiplied by 3 gives me 6 minus 1 by 1 gives me minus 1. So the determinant is equal to 7, right? So the determinant is equal to 7. So you get a mark for saying that, right? But then you need to say since the determinant, you can write the words determinant, or you could say write it as this. Since R is not equal to 0, the matrix is non-singular. right? So that's what you need to say in order to get the full 2 marks here. That's what you need to say. You need to work out the determinant, and then you need to tell them that since the determinant is not equal to 0, the matrix is non-singular, right? I want you all to work out for me the second part. They want the inverse. What is the inverse of R? Alright, I'll give you a few minutes to work out the inverse of R for me. Oh. Alright. I've seen Emily, John, Darrell, everybody else. You're on. Alright, so you want to find the inverse. So this shouldn't take you too long actually. So the inverse, R inverse, remember it's 1 over the determinant. So it's 1 over 7 multiplied by the adjoint of the matrix. So you're going to swap the positions of the 3 and the 2. So 3 and 2, that's the first thing I'm going to do. I'm going to put a minus sign here. So this will become 1. Alright, and then this will become minus 1. So this is my inverse here. So again, 2 marks just for that. 2 marks just for writing on that. Right? Then they're asking us to show this. Well, you're gonna have to multiply that to show that when you multiply a matrix by its inverse, we get the identity matrix. So the identity matrix we know is 1 0 0 1, right? And then the last part now, they want us to use the matrix method to solve this simultaneous equation. So first thing we do for this one here is to write what the matrix is. So it's 2 minus 1, 1, 3 multiplied by xy is equal to 0, 7, right? Now, most of these questions, it's usually related to what you did before. Look at something here. This matrix here, you realize it's the same matrix up here? So you already know the inverse. They're kind of guiding you on how to do the question, you know. The same matrix you just work out is required to solve this, right? So pay attention to things like that. So we know that if we have to solve this here, we're going to put 1 over 7. You're going to multiply both sides by the inverse of the matrix. So 3, 1, minus 1, 2. Multiply by 2 minus 1, 1, 3. Well, we know the left hand side is you're just going to end up with xy. And this will be 1 over 7 multiplied by 3, 1 minus 1, 2 multiplied by 0, 7. So what I want you all to do is to work out this whole thing on the side here for me, multiply that out, and I want you all to tell me what you're getting for x and what you're getting for y. Alright? So that's the last thing we're going to do. I want you all to work out x and y for this here for me. Alright, I seen John and Aaron both got 1 and 2. So what I really asking you to work out here is, so you have x, you have y, and what you're really working out is 1 over 7 by 3, 1 minus 2, 1. So this is 3, 1 minus 2, 1. 3, 1. Sorry, 3, 1 minus 1, 2. Minus 1, 2. And that's being multiplied by 0, 7. Right, so all you're doing here really and truly, you're working on the right hand side. So you don't touch the 1, 7, leave it as is for now. 3 by 0 is 0, and 0 plus 7 gives me 7. Minus 1 by 0 gives me 0, and then 2 by 7 gives me 14. So therefore, when I multiply this out, I'm going to end up with 1 over 7 by 7 gives me 1, and 1 over 7 by 14 gives me 2. So therefore, you're going to tell them x equal 1, and y is equal to 2. Alright, so this is it for matrices, right? We're not going to be coming back to this. What we're going to be doing next week, I'm going to be running through vectors next week, right? So we're going to look at the various questions that I can ask on vectors. Alright, and in the meantime, I'm going to try to finish with multiple choice exam number 8 for you guys to do. Alright, so hopefully by this weekend I should finish that, and that particular exam, please make sure you practice that exam. Most of the questions from that paper will come back in July. Alright, so I hope you all had a good session today. So be safe, and I will see you all next week. Any questions? right, so be safe and I will see you all next week.